Hi guys, welcome you all to my channel Explore Edu to Teach.
So the next topic that we'll be learning in random signal analysis is going to be introduction to random variable and solve numericals. So this is a very important concept. In this video we'll be talking about the introduction to random variable, the basic terminologies of a random variable. You have to understand those terminologies very well if you have to solve numericals on it and for the further concepts in this particular subject, because every concept is going to depend upon these terms that we are going to study in this lecture. So we'll be talking about introduction to random variable, what is a random variable, what are the different types of random variable like continuous, discrete, what are the terminologies, very important, I repeat, what are the terminologies of a random variable. It might be a probability mass function, it might be probability density function, it might be a cumulative distributive function, it can be anything. So you have to understand these concepts very well. So introduction to random variable is very important, and then solving numericals on it is equally very important. So let's try to understand it and let's try to get a better insight of it. These notes are uploaded on in the description box of this video. The links of my Google Drive link is present. Please download the notes, it will be helpful for you. Also all the formulas, okay, which are helpful in this particular concepts are always uploaded on my Instagram page also. It can be very helpful for a quick revision of a quick short notes. You can refer to the Instagram link given down in the description box. If you like that particular page, do not forget me to follow on Instagram as well. So let's begin with random signal analysis. So talking about random signal analysis, random variable, what do you understand by the term random variable? So random variable is basically the mapping of the output of an experiment onto a real scale value. So basically there is an experiment, for example tossing of a coin. It can be either be head, it can either be tail. So mapping the output of an experiment onto a real scale value is random variable. So whenever you have an output of an experiment, if mapping is done onto a real scale value, and that is the random variable. The random variable can be of two types, the discrete and the continuous. The discrete means countably infinite and continuous means uncountably infinite. So discrete means you can count, whereas continuous means you cannot count. That's a simple thing. There are three concepts over here: probability mass function PMF, probability density function PDF, and cumulative distributive function, that is your CDF. You need to know all these three concepts very well because they will be repeatedly be used in all your other concepts. So you have to understand them very well. If you don't understand them, then that can be an issue. So I'll try my best to make you understand these three terms. Make it a point that you make a note of it. It's going to be very helpful in all the numericals as well as building the future concepts in this subject. So what is probability mass function? Basically probability mass function is a property of discrete random variable. For example, we have n number of outputs of a particular event. For example, we are like tossing a coin. That can be head and tail. If you are tossing two coins at a time, there can be many more outputs. So there are different events, x1, x2, x3, xn. Each event will occur with certain probability called as p1, p2, p3 till pn. The addition of all these probabilities has to be equal to 1. That is very important. So what happens is that when you have a discrete random variable that can have different outputs of an experiment, that can be x1, x2 till xn, and the corresponding probabilities p1, p2 till pn, and the summation of all this probability is equal to 1. That's the property of PMF. So PMF or probability mass function is a discrete random variable in which x1, x2, x3, xn are the different kind of events. Each event occurs with its probability p1, p2, p3 till pn, and when you add all these probabilities, it will be equal to 1. Similarly, we have PDF. see, like you have PMF for discrete random variable, we have PDF, that is probability density function, for continuous random variable. So if x is a random variable, then the probability density function is fx of x. Please understand this symbol. This symbol is going to use multiple times and you should know what does it mean. So it's a small f, then there is a capital X, then there is a small x in bracket. This particular symbol indicates the probability density function. So if x is a random variable, the PDF is given as fx of x, that is small f, capital X and small x. Now the probability density function has value greater than or equal to 0. Next thing, the integration from minus infinity to infinity is always equal to 1. And the probability, for example, what's the probability of a random variable existing between a and b is given as integral a to b limits fx of x dx. Similarly, this probability density function is a derivative of your probability of cumulative distributive function. The next topic that we are going to learn, CDF, is this capital fxx of x. So that is very important. The probability density function is given with small fx of x, where f is small, whereas the cumulative distributive function is given with a capital F. That is very important. So what is the probability mass function? That is PMF. That is basically for a discrete random variable. There are n events, x1, x2, x3 till xn. Individually they will have probability p1, p2, p3 till pn. So the summation of all these probability value is equal to 1. Similarly, you have the PDF, which is the probability density function. It's meant for continuous random variable, and the symbol is given as fx of x, where f is the smaller letter. Fx of x is greater than or equal to 0. The integration is equal to 1. The probability for a particular random variable existing from a to b is given as integral a to b fx of x dx. And most importantly, the derivative of a CDF is the PDF. Next we have the cumulative distributive function, that is capital Fx of x. Please understand these symbols very well. Future, no one is going to write the complete form, they are just going to use these symbols. So you should understand, okay, a capital Fx of x, a capital F indicates cumulative distributive function. A small f indicates a probability density function. So you have two kind. So you have and most importantly, as I told you, your PMF is for discrete random variable, your PDF is for continuous random variable. Similarly, your CDF is for continuous and discrete random variable both. So if x is discrete, your fx of x is given as summation x is equal to xi p of I. Similarly, if x is continuous, the fx of x, that is the cumulative distributive function, is equal to integral minus infinity to x, the value of x till where we have to find out the cumulative distributive function fx of x dx. So if I have to understand, my PDF is the derivative of CDF, whereas the CDF is the integration of my PDF. That correlation you have to understand. Now, as we learn the properties of PDF, probability density function, let's try to understand the properties of CDF, that is cumulative distributive function. The CDF value will always be between 0 to 1. Fx of minus infinity is given as 0 and fx of infinity is given as 1. So these are the most important properties. So this is all about this video. We learnt about what is random variable, the three important terminology. If you haven't understood, please comment in the comment section if you understood or not, because these topics I want you to understand very well. PMF, PDF and CDF. this is just the theory part. In the next lecture, when we solve the numericals, I guess you'll have a better understanding about it. Okay, so if you like this video, do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram as well. The links are given down in the description box. Thank you so much guys. God bless.